Whenever you visit a web page and you log in with your username and your password, you want to make sure that the website that you're submitting your information to is served over SSL. And that basically means that your connection with the server will be encrypted so someone can't just see your password in plain text. For example, on Drift and Ruby, you can see that we have our connection and Google Chrome shows that this connection is secure. However, just because your connection is encrypted doesn't mean that someone can't get your password through a man-in-the-middle attack. So what we're going to look at today is encrypting the password on the client side before it ever leaves your browser. So once you type in your password and you hit the login button, it will encrypt the password using a RSA public key, and then once you submit that information to your web server, it'll send over the email in plain text, but then your password will be encrypted. And again, this would all be served over SSL, so there is already one level of encryption there. However, we're going to add a second level just in case if our end user is a victim of a man-in-the-middle attack. And once that password is submitted to the server, it'll be decrypted with the private key on the server side, and then it'll be able to validate whether or not the user email address and password is correct. So to accomplish the client-side encryption, we'll use the library JS-Encrypt. And the documentation is really good on this library. At the very basic, you're setting a new instance of the JS-Encrypt, then you're setting the key. In our case, we'll be setting the public key, and the public key can be used to encrypt the data. We'll then capture our password text, and then we will encrypt the text. And in our case, we're going to set this encrypted text back to our password field, so the password in plain text is never sent over, just as encrypted text instead. So to get started, if you go to the GitHub repository and then under the bin folder, grab the jsencrypt.js file, and you'll want to put this into your vendor folder within your Rails application. So under the vendor, assets, JavaScripts folder, I have the jsencrypt.js library. And then in your application.js file, you'll want to require this JS-Encrypt library. So we'll go ahead and create our JavaScript necessary to do this client-side encryption. So first I'll check on the TurboLinks load. We'll create a listener so that the form is submitted. We'll then run this event. We can then set our JS-Encrypt to a new variable encrypt. And I'm going to do something a little bit different just to make this a bit more expandable. So I'll create a data attribute called encrypt, and I'll just set this to true for each one of the fields that I want to encrypt. Then just for simplicity, I'll set the unencrypted variable equals to this. So since we are looping through each one of our form inputs that has this encrypt equals true, then we get access to that input as this. We will then need to set our public key, and we'll come back to this yet because we haven't yet provided our public key to the client. And then we can get the value of our input for the unencrypted with the unencrypted.val. And we can wrap this around the encryption. So if we use our encrypt, we can call encrypt.encrypt because encrypt is what we set our JS-Encrypt library to. And then we pass in our input from our form field that we want to encrypt. And there could be a case where we post information to the server, but because of the validations on the server side, we get returned back to this page, and we want to make sure that we're not re-encrypting encrypted values. So I'm just going to put in a check where the encrypted is not equal to false, meaning that the JS-Encrypt failed to encrypt the library, and I've seen that happen when you try to encrypt an encrypted string. If it did encrypt it correctly, then we can set our form input's value to the encrypted text, and then that'll get silently posted over to our server. So within the root of my application, if you just run this command, the openSSL genRSA, then it'll create a 1024-bit private key. You can then call openSSL RSA pub output, taking in the private key, and then outputting a public key. And it is this public key that we have exported that we will freely give to our client side so they can encrypt the form fields. So if you go to your view that has the login form, on the password field, because we are using a data attribute encrypt, we can create the data attribute and then call encrypt true. Then we also need to pass in our public key. And I don't like using an attr accessor because there's no reason why we need to send this public key back to our server. And instead, I'll just create a hidden field tag at the bottom here with that public key. And within your application, I recommend not putting it in plain text here, because if you ever need to rotate your keys or something like that, then you may run into some issues. Also, you shouldn't be posting this up to your repository. Instead, you may want to just have a generator where you can generate these on the production server and then share it off with however many web servers that you have. However, in our case today, just because that is a bit different of a topic and it does add a level of complexity, and in fact, you know what, I'm just going to set these as a global variable, actually just on our application.rb file, because this will get loaded in. I'll just create a public key and then I'll just paste this in. So now we can access our public key wherever our application's at. And again, you may want to put this into your secrets or something where it's not posted in plain text and submitted to your repository. And then we can do the same thing for the private key, where the private key is just going to have this plain text as well. So now we can copy our public key, and then we can just reference that here. And now that we have access to our public key on the client side, we can call the public key.value, and that's going to return the actual public key. So for our testing purposes, I'm going to add a event.prevent default, and this will prevent the form from submitting. And I'll just change this password field to a text field so we can actually see our password being typed. So back to our site, if we fill in our email address, and then if we type in a password, once we hit login, we would expect this password to be encrypted. And it is. So now we no longer have access to that plain text password, but now we just have a base64 encoded encrypted password. And once we get over to the server side, we'll decode the base64, and then we'll be able to decrypt the password. So on the server side, we have a normal session handler for devise. And this create action is our post that we take in from our user's sign-in page. So first we're setting our resource, which is our user, to the warden.authenticate, and we're passing in this auth options. So if a user provides a bad username and password, then it's going to fail gracefully here, and then you'll get your error message. And then it continues to set a flash message, signs in, and then does some redirects. So we're going to have to modify this a bit, because we're not going to be able to manipulate the parameters and then still use the warden authenticate. However, we can do something fairly similar. So I pasted a bunch of this stuff, and let's have a look at it. We have our self resource with the warden authenticate commented out. We're just then going to set our own resource, and we're going to find our user by the email address, and we're going to pass in the parameters that the user submitted. We'll then check to see if the email address was found. So this resource ampersand dot, that's the same as doing something like this, where you have your resource and then your resource. So you're checking if the resource is defined and if the resource has a valid password. So in our case, we'll check to make sure that the resource was found, and then we'll validate the password. And the password is encrypted, so we'll need to have some kind of method that's going to decrypt the password. So I just have a private method down here where we have our authenticate encryptor. And this authenticate encryptor is just going to take in our private key that we set in our application.rb file, and we take our password from our user input, and then we'll return the private key, and then we're doing a private decrypt. And again, remember, we have to decode the base64 first, and then we pass in our encrypted password. And this should return the plain text of the password that the user submitted, and then we can validate our password off of that plain text password. And the rest of this is the same as the original, where we're setting our flash message, signing in, and then doing some redirects. Otherwise, if the user was not found, or if it's a bad password, then we're just going to take the user to the new session path and alert bad email or password. So going back to our application and refreshing, off camera I did revert back the changes of the input field, change that back to a password, and then I also commented out the event prevent default so we can actually test posting this form to our server. So I'll put in my username, and then I'll type in my password. I'll hit submit. We saw that it did get encrypted, and then on the client side, we now have our login session. So this may seem overkill, but it does have some good instances where you can use this in your models and create callbacks, so you're always sending and receiving encrypted data. For example, if on your client side, if you need to take in someone's social security number, you can do the same thing where it's encrypted just by having a data encrypt true attribute on there, but then have a callback in your model that'll first decrypt the social security number and then save it. That way, whenever you're posting your social security number, it's not actually sending it over in plain text over that SSL connection, but it's first encrypting it and then sending it to the server for decryption. And likewise, when you go to display that data either in a form field or in text, then you can encrypt it on the server side first and then send it over to the client side for decryption so that it's being protected there as well. Well, that's all for this episode. Thank you for watching. For more videos, check out driftinruby.com.